Hello guys, welcome back to my channel, Mason African Motives. Still working on mathematics N1 so we shall actually have a continuation working on question papers and revisions. So in this platform we shall be working on the question paper which was written actually in July 2018. If you see, most of these question papers, they are very important how you attempt them. So we shall actually see what we have from this question paper, which is actually an X paper for mathematics N1. So remember, we have the instructions and the information that you actually be given. So make sure that everything there, you read it, everything you must read it. All right, so the first question that we're actually having, that is the first part that we had, and that these are the questions that we're given actually. All right, so shall we just quickly rush through these questions and see how we're supposed to attempt them. So the first question is to simplify the following without using a calculator and by making use of exponential and or, take note, it's either you can apply both logarithmic laws. So that is what we had. So that is the first question here, is 2 marks actually on 1.11, which is a squared b to the exponent of 3 times a to the exponent of 4 b to the exponent of 2. So this is what we had, and it's 2 marks now. As you can see, it deserves 2 marks because there what you are simply doing is to add, because you are multiplying bases which are the same, so you have to add the exponents, which is 2 plus 4. All right, then b, you do the same for b, 3 and 2, which is 3 plus 2. So remember, when you're multiplying the bases which are the same, you add the exponents, which is 6, and b to the exponent of 5. So that is 2 marks for that, yes, and it deserves that. So let's see what we had on 1.12, which was 3x to the exponent of 3, y to the exponent of 3 to the exponent of 3 again, times x to the exponent of 4, like this, everything to the exponent of 0 over xy squared to the exponent of 2. Yeah, that is what we had, and it was actually 4 marks here. This is actually 4 marks, guys, as you can see. So which part are we going to apply? Which concept are you going to use? All right, let's see the first stage. From the first bracket, we have an exponent of 3. So remember, the exponent can affect everything, the whole bracket, which means it's 3 to the exponent of 3, which is actually 27, because it's 3 to the exponent of 3 like this, which is 3 times 3 times 3, which is 27. So this is going to be 27, and here this is an exponent and there's an exponent. So take note, guys, from your law that you multiply x to the exponent of a to the exponent of b gives you x to the exponent of ab. You multiply the exponents. So in this case, you multiply 3 and 3, which is 3 times 3, that is 9. All right, then you do the same for y. Here is 2 times 3, which is 6. Multiply by, yes, here we could have applied the same concept, but guys, this is to the exponent of 0, and we know that anything raised to the exponent of 0, whether it's a bracket, as long it is raised to the exponent of 0 like this, it gives us a 1. So this whole thing gives us a 1. All right, everything over, we do the same. Here this one is same as x to the exponent of 1, so you're going to multiply just like what we did here. So it's 1 times 2, which is 2, then 2 times 2, which is 4, so it's y to the exponent of 4. Then which part now are we going to apply here? Because this is the stage. Okay, we know that 1 times a number, this is going to remain as it is, just like 27, x to the exponent of 9 y to the exponent of 6 over x to the exponent of 2, y to the exponent of 4, like that. So this is what you're going to have at the end. And here this one is same as 1, so it's like 27 divided by 1, which is just 27. So what are we going to do now on these two which are dividing? Because these two, they are dividing and they are the same bases. As you can see, it's x and x, so we have to subtract the exponents, which is 9 and 2, which is going to give us x to the exponent of 7. So this is going to give us x to the exponent of 7. The same with y here. Subtract 6 minus 4, which is 2. So that is what you're going to have. Because the bases are the same, so we have to subtract the exponents because you are dividing the bases which are the same. So that is the idea or the concept on how you attempt such questions. Then another question we are given to simplify, it's a mixed question, a log, this and that. Let's just see what they wanted us to do there, because we are given the square root of 7/3 minus 3 squared, like this. All right, let's see what they want, what they are trying to say here. All right, this is plus and this is plus here. This is plus log 6 base 6, like this. All right, so and 4 marks for that. As you can see, it's actually 4 marks again. So actually these guys, they'll be trying to play around us to see if we understand the concept there. So how are they trying to play around this time? Here, what are we supposed to do? Definitely I have to start with the bracket, expand this, which is negative 3 squared, of which negative 3 squared simply means negative 3 times negative 3, which is positive 9. All right, so you're going to obtain positive 9 there, which means this is going to be the square root of 7/3 here minus this part here, which gave us 9. All right, we shall talk about this later on. Let's come here. Y squared, y to the exponent of 0. Remember, anything to the exponent of 0, it's a 1. So this is going to give us a 1 times 2, which is 2, plus here we are adding. And remember from our logarithms, I told you guys that logarithm of a in base a is 1. Then log, the base and the number, when they are the same under a log, the answer is going to be a 1. So this is definitely a 1 here. All right, but remember there is something that is referred to as BODMAS, guys. We can't add these two. We have to multiply first, which means this part. Okay, so that means simplify this. 73 minus 9, that is gonna give you 64. So it will be square root of 64 times 2 plus 1. And what do we have on square root of 64? A number that's gonna multiply itself to give us 64, that is 8. So this one is 8 times 2 plus 1. I'm keeping this part because you can't add. We have to multiply first, then we add. So we have to multiply here 8 and 2, which is, if we multiply 8 times 2, that is 16 plus 1. Take note, guys, your BODMAS, which is 16 plus 1, that's going to give you a 17. So this is the rightful answer that you're supposed to get there. The BODMAS still exists in mathematics, so you have to apply it. All right, it's not like something that was used before that we no longer use. No, it still exists, so we have to apply that. All right, then what we have here, as you can see, guys, we are adding the 2, and we know from our laws of logarithms that we have to multiply. So it's 25 times 4, which is going to give us 25 times 4, which is 100 in this case. But can we leave our answer like log 100? We know that log 100 is equal to 2. So this part you're supposed to know it. I think I talked about this logarithm of base 10 from logarithm of 1. Say logarithm of 1 in base 10 is a 0. Logarithm of 10 in base 10 is a 1. Logarithm of 100 in base 10 is a 2, and so on and so on and so on. So you can't leave your answer like log 100, it's a 2. All right, then what about this part here on 1.22? what do we have there on 1.22? Okay, let me just try and adjust here. We had log 8, log 8 everything over log 7 like this times log 49. All right, everything over log 4 like this, and this is actually 3 marks to make it 15 on question number 1. All right, an interesting question actually, because here they wanted you to understand the basics of logarithms there, because as you can see, we are actually in base 10. We are not going to assume the base. We know that in base 10 because the base is not written, so it's in base 10. But how can we simplify these two? They're multiplying, and we do not have laws under logarithm about multiplication of logarithms. We do not have. If you have one, then you can actually give us on the comment section, but we do not have any. So how can we at least maybe write it in a way that it can be simplified? Which way can we choose? All right, we can at least write these numbers in the same number, like to express 8 and 4 in the same numbers, 7 and 49 in the same number, that is in the simplest form. So which number can we choose for 8 and 4? Because these two, they have something in common. So 8, we can write this in terms of 2, which is 2 to the exponent of 3, because 4 is 2 to the exponent of 2. So we can write this in terms of 2. All right, over 7 is already in simplest form. There's nothing that I can do to 7, maybe just to write the 7 to the exponent of 1, because it's just like 1, there's no effect there. All right, so that means I can write 49 in terms of 7. Why? Because 49 is same as 7 to the exponent of 2. Remember that 7 squared, that is 49, over 4 in terms of 2, which is 2 to the exponent of 2. Why are we writing in terms of same numbers? All right, we shall see that one later on. Let us apply this law first so that it can be clear. I want you to see something. We have got an exponent here, and remember from our laws of exponents, I told you guys that p log m is the same as log m to the exponent of p. So that means before it was p log m, now it's log m to the exponent of p, which is this format, this one. So this format can be written like this, which means you can drop the exponent and it will be 3 log 2, just like p log m. All right, over this one is going to be 1 log 7. So it will be 1 log 7 times, you drop the exponent here, which is the same as 2 log 7. So it's one and the same thing actually. You drop the exponent here, which is 2 log 2, which makes something magical there. And what part are we talking about? Because we know that once we are multiplying, if you have got x over y like this times y over x like this, you can cancel the numerator and the denominator. That is possible. So you can cancel log 7, and log 7 is very, very possible now because we are multiplying. Log 2 and log 2 can cancel. 2 and 2 can cancel, which means you're going to be left with 3 over 1. All right, so that means everything here is going to give us 3 over 1, which is same as 3. 3 divided by 1 is 3. So that is all that we had from this question, guys. As we can see, applying basic concepts of logarithms and concept of fractions also, because this was a combination of logarithms and fractions. How do you work out fractions and so forth and so forth? All right, divide, that is question 2, this whole expression by x plus 2. Remember guys, I always tell you that the order is very, very important here. So this is x cubed like this, so it must be followed by this one with x squared, so it's plus x squared like this, followed by minus 4x, all right, followed by negative 4 like this. So this is what you're supposed to have, and now you can actually divide properly. All right, so let's divide, guys, together. So what are we actually dividing here. All right, this is 2.1. Remember what you are dividing by, x plus 2, this one. So it's the one that you're going to start to write here, like this, long division. So this is x plus 2. It's being divided by this, so into this, so which means you have to write this inside now, which is x cubed like this, plus x squared minus 4x minus 4, like that. So that is what you're gonna have, and now we can divide properly. Remember the concept, guys, that I always tell you: divide first. Always is the first term and the first term. So it's x cubed divide by x, x cubed like this, divide by x, which is gonna be 3 minus 1, which is 2, so it's gonna be x squared. So it will be x squared. So it's this one divide by this one, which is x squared. Then you multiply back everything here, everything. So it's x times like this, x squared into x plus 2 like this. So we multiply everything, which is x squared times x, that's x cubed, x squared times 2, because it's going to multiply everything, which is 2x squared. So that's what you're going to have. And after multiplying, remember the concept, you have to subtract. So you subtract here this from that one. So what are you going to have if you subtract, guys? As you can see, x cubed minus x cubed, these are the same, so they can actually cancel out. And this is same as 1 here. Here the same, there is a 1 here. So it's not different from 1 minus 2, of which 1 minus 2 is minus 1. So you're going to have minus 1, which is minus x squared. Same as minus 1x squared. All right. So remember that after subtracting, you have to drop the other terms which are remaining, which is negative 4x, negative 4, like this. These are the terms that are remaining. Okay, then we divide back again, negative x squared divided by x. So we are now back like the first term divided by the first term. So it's like this, negative x squared divided by x. So as you can see, it's gonna be negative x, because it's 2 minus 1, which is 1, minus x. So it's gonna be minus x, this one. Whatever that you get, it has to multiply back, just like what we saw here on x squared. So this minus x has to multiply this one. So it's minus x times x, like this. So it's supposed to be minus x into x plus 2. It multiplies everything. So minus x and x, that's going to be minus x squared. Minus x and plus 2, take note, it's minus and plus, which is minus 2x. All right, then we subtract again, just like what we had previously. After you multiply back, you subtract the 2. So let's subtract the 2. As we can see, these two are the same. So once you subtract, you're going to obtain a 0 here. All right, then here it's minus 4 minus minus 2. Take note, guys, minus 4 minus minus 2. So this is going to give you, from your calculator, it's going to give you minus 2, because it will be minus 4 plus 2, which is minus 2. So you're going to obtain minus 2x minus 4, like this. So we drop this negative 4, so it will be negative 4, like that. Then we have to multiply, we have to divide again, so that we can multiply. That is what you're going to do in this case. So if we divide, this is going to be minus 2x divided by x, which is minus 2. So this one is going to be minus 2. So take note, guys, minus 2x divided by x, which is minus 2, because it will cancel like this, minus 2x over 2. So this will cancel, which is negative x, which is divided by x. Sorry, this is by x. So x and x will cancel. You remain with minus 2. Sorry. So, and minus 2 multiplies back here. So it's minus 2 times x, which is minus 2x. Minus 2 times this one, which is these two, so it's minus and minus and a plus, which is a minus, and 2 times 2 is a 4. So remember, we have to subtract just like what we were having later on. So as you can see, guys, these two are the same, minus 2x, so it's actually a 0. Minus 4, the is minus 4, so it's actually a 0 there. And also, we do not have anything to draw because all the elements have been used here, so there is nothing left to give here. So that is what you're just going to remain with. So as we can see, if we divide these two, we are going to obtain this as our resultant. So this is your answer there on top when you divide by x plus 2. So that is the consideration actually, and how you answer. So supposed to be very, very careful how you attempt these questions. And the other part is to subtract. Always I told you guys, this is what is important when they say subtract this from this. From, that is what is important. From is where you are starting at, so this is the one that is going to subtract this. So from this, so we start with this, which is 2.2. so it's from what? From this, which is 3 plus x minus 2x squared. That is where we are going to subtract this whole part, this one. It's subtract this part from. So from is the one that subtracts this one. Okay, so it's minus, open bracket there, write everything as it is, minus x squared plus 3 like this. So you write everything as it is here. So this one, there's no need of you writing it in a bracket because it's the one that is subtracting another term. As the minus is going to affect here, not this part. So there's no need for us to put this in a bracket. All right, so this one is just gonna repeat as it is. Just repeat as it is, then we can multiply by minus. So it's minus times 7, which is minus 7x, minus times minus 8, which is a plus 8x squared, minus times plus 3, which is minus 3. So that's what you're going to have. Then we can collect like terms. So as we can see, we've got 3 minus 3, which actually gives us a 0 there. So we are left with x and 7x. So this is same as 1 here. So it's 1 minus 7, of which 1 minus 7, that is minus 6. So it will be minus 6x. All right, we are done here. We move on to minus 2x squared plus 8x squared, because these are the like terms. So it's minus 2 plus 8, which is 6x squared. So that is what you're going to have at the end after you have subtracted. So this question was actually just for you to subtract, nothing much, just subtract, you're done. So the language there is very, very important. What are you subtracting from, and so forth. It's very, very important there. Then on 3.1, we are actually asked to factorize the following expressions fully. So here, what do we have on the first part? I didn't see, in fact, I can't see anything that is common except for 4. So maybe you can just factor out 4 here, which is 24x divided by 4. Remember, when you factor out, you divide. So it's 24x divided by 4. So 24 divided by 4, which is actually 6. So it will be 6x. Then minus 12y x squared divided by 4. So it will be minus 3. 12 divided by 3 by 4 is 3. So it will be minus 3yx squared like this. Then we've got 16. This is just 16, this one. So 16 divided by 4, that is plus 4. There is nothing like y squared there. It's just a 4. We do not have y squared here. We have got 16. And it's only 4 which is common. So if you factor out 4 here, it's just going to give you a 4. So please, you must correct that. All right, then on 3.12, let's just write it down. 3.12, there we've got 5a squared plus b into a squared plus 5. So sometimes they can give us this type of equation when these two can be the same when you factor out, but in this case it's not the same, because yes, the bracket here is they've already factored out, but what is remaining here outside of the bracket, there's nothing that is common. So which means we have to expand this bracket and go back to its original format. So let's expand it. It's going to be 5a squared plus, this is b, so this is b times a squared, so it's gonna be a squared b, like this. This is b times 5, which is going to be plus 5b. Then the bracket is done. We have got b squared at the end, like this. All right, so we have got 4 terms there, and remember, when you have to factor out, you have to take terms which are common, where there is something that is common. So in this case, I want you to see something, that if we are to rearrange these two terms together, all right, which is 5a squared plus 5b, and arrange these two terms together, because there's something that is common, which is b. We can factor out from these two terms here. All right, so let me write it here. So I'm going to write plus a squared b plus b squared. All right, let's see if this is going to make sense. If not, then we have to redo it again. All right, what we have here, if you can see, 5 is common here, so you can actually factor out 5, because remember, when you've got 4 terms, you rearrange them into 2 like this. Then you factor out what is common for the first 2. So 5 is common, we can factor out 5 like this. And we have to divide 5a squared divided by 5. This is going to cancel, which means you remain with a squared plus 5b, and 5 and 5 will cancel, which means you're going to remain with b. So you assume as if you are cancelling, but you don't cancel the numbers. All right, the same here, b is the one that is common, but you are going to factor out plus b, so that this will be a squared b, like this, divide, it will be like this, a squared b over b. So as you can see, b and b will cancel, we are going to remain with a squared plus b squared divided by b, it will be like this, b squared divided by b. So as you can see, this is going to subtract 2 minus 1, which is 1, so you're going to left with b to the exponent of 1, which is same as what? Which is same as b. Now as you can see, these brackets are the same, which was our main focus or our main aim, to make sure that these brackets are the same. Why are we focusing on this? Because we can now factor out the common bracket, which is this one, which is common here. So we can factor out a squared plus b like this. So if we factor out this bracket, what is going to remain? We are going to remain with 5, and here we are going to remain with plus b. So you combine these two, it's now a bracket. So that was the concept there. So as you can see, guys, that whatever that you have or whatever that you're going to be working on, it's very, very important to understand the basics of factorization, because question papers, they give you what you have studied and combining with other areas. So it's not about only one topic, but also understanding of numbers and so forth. It's gonna make things much easier. Okay, anyways, let's see what we had on 3.12, which is to simplify the following. And that was just to simplify, and it's actually 4 marks. And let's see why 4 marks. Let's see why is it actually 4 marks there. All right, it was x squared over 2 plus 2x squared over 3 minus 7x squared over 6. So actually this is what we had. So what can we do, guys? We are adding, we are subtracting at the same time. We actually know that once we are given such type of a question, you have to find the LCD, which is actually the LCM of the numbers, which is the lowest common multiple of 2, 3, and 6, which is actually this one. We can actually see by sight, we can see that it's 6 there. So remember, after obtaining your LCD, you have to divide back. It's LCD divide by the denominator here. So it's 6 divided by 2, which is 3. All right, that 3 multiplies the numerator here, so it's 3 times x squared, which is 3x squared, plus 6 divided by 3. Take note, guys, 6 divided by 3, which is 3. That 3 multiplies the top here, so it's 3 divided by 6 divided by 3, which is 2. Sorry, this is 2, and this 2 multiplies this 2 on top, which is 2x squared, like this, minus 6 divided by 6, which is 1. So this 1 multiplies the 7x squared, which is on top. That is the idea there. So take note, guys, is your LCD divided by the denominator here. 6 divided by 2, which is 3. Whatever that you get, you multiply to x squared. All right, so let's see what you're going to have at the end. This is going to be 3x squared plus 2 times 2, which is 4x squared, minus 1 times 7, which is 7x squared, everything over 6. So as we can see, we can add 3 plus 4 there, which is 7. So we've got 7x squared minus 7x squared over 6. Oh, guys, 7 minus 7, that is a 0 there, over 6. And that's going to give us a 0. So that is the concept there, because we've got 7 minus 7, and that's 0x squared. So which 0x squared is same as a 0, guys. So nothing much or nothing important there. Let's see on 3.2, actually, again, to simplify, but this time it's a little bit different from what we had. This time there is involvement of division, multiplication, which is actually something that you supposed to link with factorization there. We have to link with factorization because these are now expressions, so it's different from the previous part actually. But let's see how we're supposed to do it. So most questions actually, what they do is that they can give you everything at once, just like this, a plus and a minus. Here we've got a multiplication, so whenever you're multiplying, there's no effect. This is gonna just remain as it is. I'm worried about this part, which is dividing. Take note, guys, whenever you're dividing, introduce multiplication, then you invert the second fraction, you interchange the second fraction. So we are going to introduce multiplication there because it's dividing. All right, so it's going to be times, the moment we multiply, now interchange. So this one is going to be written on top now, y squared minus y. So y squared minus y on top now over x. So this will be x now. Then we can apply our factorization. Now everything is under multiplication. It's now easier for us to work down whatever that we need here. So if we can factor out x is common on this one, so that's x squared divided by x, which is x, minus 4x divided by x, which is going to be minus 4, actually, like this. All right, everything over 4y like this, times, okay, we'll just cancel at once. Let's just factorize at once. So okay, here there's nothing. Let's just rewrite as it is, which is x minus y as it is. Then here we've got y, which is common, so we can factor out y here, which is going to be y squared divided by y, which is y minus y divided by, which is minus 1. So it will be y minus 1 actually over x. So that's what you're going to have at the end. All right, is there anything that is common here? Let's see if we have anything common so that we can cancel. That is 4 here, and 4 can cancel, y and y can cancel. All right, we've got x and x here can cancel. All right, x here and x can cancel, y here and y here can cancel. All right, so take note, we do not have anything that is common that can cancel now, so we just have to multiply what we have on the numerator. We've got x minus 4 and y minus 1. So it's x minus 4 into y minus 1 like this. Everything over x minus y like this. So that's what you're going to have at the end. So as we can see, guys, we have simplified and there's nothing common that we can do, so we do not force questions to cancel out. Once it can't cancel out, leave it like that when you can't cancel. All right, so most of us, we try to fight against the question so that it can at the end cancel. No, when it is not possible, then you just have to leave it like that. All right, let's see what we had on 3.3, which was to actually make it a total of 20 marks. All right, so determine the lowest common multiple. All right, and the highest common factor, all right, which is the HCF of the following algebraic terms by making use of prime factors. All right, so let's see. This is okay. Let's start by this, guys. 5, there's nothing that we can do here, so this one we just have to rewrite as it is. It's 5 m squared n to the exponent of 4, and that is L squared like this. That one is L. Okay, this one is L or I there. Okay, then this is 15. So actually for 15 we have got prime factors of 3 of 15. The smallest is 3. 15 divided by 3, which is 5. 5 divided by 5, which is 1. So actually 15 is same as 3 times 5. All right, so this is gonna be 3 times 5, and this one is going to remain all the m as it is. So it's m n cubed and L like this. All right, then what about 10? 10 actually, which numbers? 2. Smallest is 2, 5, 5 and 1. So it's 2 times 5. 2 times 5, and everything is going to remain this one as it is. So it's gonna be m to the exponent of 3 n L to the exponent of 4 like this. All right, so this is what you're going to have. Okay, so let's start with the first question, which is actually the LCM, which is the lowest common multiple. Then we move on to the HCF. All right, so the LCM, guys, is actually the lowest common multiple, which is you take everything that is present, every term that is present. So we have got 2 times, we have got 3 times, we have got 5 is common. We just take as it is. We do not repeat terms. So you take all the terms which are there. Okay, when you are now referring to these letters, you take the one with the highest exponent. For LCM, you take the one with the highest exponent. So it's m to the exponent of 3, n the highest exponent to the exponent of 4, L highest exponent to the exponent of 4. All right, so you can multiply these numbers here, which is going to give you 30. 2 times 3 is 6 times 5, which is 30. Yes, m to the exponent of 3, n to the exponent of 4, L to the exponent of 4. That is going to be your LCM. All right, then the HCF now is going to be, all right, the HCF, remember, you take what is common. What is common throughout. You do not take everything, but you've got 5 here. 5 is common, so you're going to take 5. All right, when these terms, they are common, but you take the one with the smallest exponent, with the smallest exponent this time, which is m is the one with the smallest exponent, is m to the exponent of 1. So you've got m, n, the one with the smallest is this n, L is this one, the one. So HCF, you take with the one with the smallest. It must be common, but with the smallest exponent. LCM, you take every term as it is, every term as it is. But when the terms are common, you take the one with the highest exponent for the LCM. So that is the trick between the two, the LCM and the HCF. And as you can see, it repeats now and again. They repeat the same thing now and again. All right, so we just need to work on question papers and revisions so that you can understand much there. Okay, solve the equations. So for x, actually, these are the equations that we are given. 4.11, which is 5 into x minus 4, which is equivalent to 3 into x minus 2. So there's nothing there. It's a matter of expansion of brackets and so forth. So 5 is going to expand, which is 5x, 5 and minus 4, which is minus 23, and x, which is 3x, 3 and minus 2, which is minus 6. Then actually I have to collect like terms. So 3x to 5x, there is going to be 5x minus 3x, which is equal to, transpose negative 20 to this side, is going to be plus 20. So it will be 20 minus 6. So that's this one to this side is minus 3x. So it's 5 minus 3x, 5 minus 3, which is 2x, is equal to 20 minus 6. And that's actually 14 there. So you can divide by 2 to find x. So x is going to be 14 divided by 2, which is 7. So that is the whole idea there, guys. Expansion of brackets, collect like terms whenever they are, then you can solve. All right, which was the same thing, but here I could have opted another way. But anyways, let's just do what most of us understand here. All right, so this is going to give us 12 because the same thing, you can expand brackets or you can divide by 3. It was another way. But if you expand, this is going to be 3x, 3 times minus 5, which is negative 15, is equal to 12, like that. So we then transpose 3x is this one to this side, which is going to be a plus 15. So that is going to give us 27. All right, then find x, divide by 3 there. So your x is going to be 27 divided by 3, which is actually, that's a 9. So like I was saying, that we could have just done this. 3 into x minus 5 is equivalent to 12, like this, because this is actually out of the bracket. So I can just divide by 8, divide by 3, divide by 3, like this. So x minus 5 is equal to 12 divided by 3, which is 4. I want to calculate x, so I'm going to transpose 5 to the other side of the equation. It's going to be a plus 5. So it will be 4 plus 5, and my x will be a 9. So many ways. So many ways of working out mathematics, guys. All right. So on 4.2, we have a certain question which was actually something else. Let's just try and understand what was happening here. We have got two people, that is, Sarah is 5 times as old as Mavis. After 4 years, Sarah will be 3 times as old as Mavis. Calculate their present ages. All right. We presently, okay, this is what is happening. We've got present and later, after 4 years. After 4 years. All right. So if we are to cross-check here, Sarah is the one who is given her age in terms of Mavis' age, because they are saying she is 5 times as old as Mavis. So it means we can relate according to Mavis' age to say that let Mavis' age be x, present. So that means the one for Sarah is going to be 5 times, which is 5 times, like this, the one of Mavis, which is x. So 5 times x, which is 5x. So this one is going to be 5x. Then they are now saying after 4 years. Okay, let's not talk about these two. Let's talk about these guys after 4 years. Which means if Mavis was x years, now after 4 years, Mavis is going to be x plus what? X plus 4. Isn't it? That is the case. If you are 20 this time, then 24. If you are 30, then 34. If you are 50, then 54 after 4 years. Sarah is 5x, present is 5x. So after 4 years, the age is going to be 5x plus 4. This is about their ages after 4 years. But they are saying after 4 years, Sarah will be 3 times as old as Mavis. All right. After 4 years, Sarah will be 3 times as old as Mavis, which means these are their ages after 4 years, these ones. And they are saying this Sarah, this one, her age, this one that we are seeing, this one, which is 5x plus 4, which is after 4 years, is equivalent to 3 times as old as Mavis after 4 years. And Mavis after 4 years, it's x plus 4. And they are saying this one is going to be 3 times, which is 3 times I have to multiply x plus 4, which is after 4 years. So this is a condition of after 4 years. So we have formulated an equation that is going to help us to find the value of x to represent Mavis' age present, and we can find Sarah's age, which is 5x, once we have the value of x here. So you see how tricky the question was. You are going to formulate an equation from this one of after 4 years, because that is where you are given a condition. This is after 4 years, so you're not going to use their ages at present, but these ones that they have after 4 years. Okay, anyways, now like this is now a normal equation. We have to just expand brackets. 3 times x, which is 3x, 3 times 4, which is 12. Collect like terms, that's gonna be 5x. 3x to this side is going to be minus 3x, is already we've got 12. 4 to this side is going to be minus 4. So that is here 5 minus 3, which is 2x, is equivalent 12 minus 4, which is 8. So divide by 2 by 2, that's our x is going to be 8 divided by 2, which is 4. And remember, x represents the years at present for Mavis. Mavis at present, her age is x. So that is what we need. So Mavis is having 4 years present, and the one for Sarah now is 5x, which is 5 times 4, so it will be 5 times 4, which is 20. So presently Sarah is 20 years. That is at present, because remember that is what we had at present. Then after 4 years, this is the condition of after 4 years. If they ask the year, their years after 4 years, then this one was going to be x plus 4, which is 8. And this one was going to be 5x plus 4, which is 24. So that is what you're going to have. But in this case, they said, what is their present? Their present ages. So these are their present ages that we are given. So it was a tricky question, actually, very, very tricky. And you have to be very, very careful when answering such typical questions. The volume of a cylinder is, we are given the formula for the volume, then make R to be the subject of the formula. All right, so there they just want to take you back to change of subject and so forth and so forth, where we are given the volume. It's 4.3. So it will be like you are solving actually an equation. You'll be solving an equation. All right, so we want to make R to be the subject. So which stages are we going to take, guys? As you can see, these two, they are multiplying. So we can remove these two by dividing. Pi h divided by pi h. So pi and pi can cancel, h and h can cancel. So that will be R squared is equal to this one. R squared will be equal to this whole part here, which is v over pi h. All right. So how can I make R to be the subject? There is a square. How do you remove this square here? You introduce the square root both sides like this. So to remove a square, you introduce the square root. Once it's like this, it neutralizes and you are left with R there, which is the square root of v over pi h. So it will be the square root of v over pi h, like that. So that is going to be our R. Take note, they told us that this is the volume of a cylinder, so you're not going to write this as plus or minus, because we know that the R there represents the radius, so it can't be a plus or minus, so you just have to write it as a plus. That is our radius there. Then they now later on give us on 4.32, if the volume now is equivalent to 630 cubic centimeters and the height is 5, then find the value of R. So this one is just a matter of substitution into the formula. I don't know, this is 4.32. You're not supposed to do this, you're supposed to write it on a fresh page, guys, okay? But because I want you to see the answer only here. So V, that is our volume, which is 630. So it's 630 over pi h. So pi, just write it as pi times h, which is the height. So this is our height. Take note also, this must be centimeters, cubic centimeters, and this one must be centimeters. The units there must be in the same accord. That is what is important. So you've got the square root of 630 there over pi times 5. So you can actually use your calculator. You obtain a decimal like 6,33301, something like that. So that is your R, the 6,333. You can just put it to 3 decimal places, or if you want. So just by the use of a calculator, guys, sorry for that, which is just the square root there, you put a fraction 630 over pi, shift pi times 5. All right, so you've got your answer there. There you go. So that is what we had. And the other part, which is actually on question 5, was study the graph. There you are asked to study something that is there, saying take your time on that graph and understand what is happening there. Okay, so the first question is on 5.11. Write down the coordinates of A and B. Okay, the coordinates of A. So take note, guys, this is the y-axis. In the y-axis, we know that x is equivalent to what? X is equivalent to 0. So which means the point A is going to be 0, 6. Already the value of y, this is the value of y here, which is 6. So it's 0, 6. And B, this is the x-axis, and in the x-axis y is equal to 0. So this is the value of x. So your x is minus 3, your y is as 0, like this. Remember, a point is given in terms of x followed by y, like that. That's a point. You start with x, then y. All right, calculate the gradient of the straight line. So now we've got this A and B, so you can use them to calculate the gradient, which is, we can actually take an increase in y over an increase in x, like this, minus 6 over minus 3, which is going to give us 2. But we can actually apply the points, okay, because this is your x1, y1, x2, y2. And remember that gradient is equivalent to, that's gradient, which is m is equivalent to y2 minus y1 over x2 minus x1, so which is y2, that's s0 there, minus 6. So it's 0 minus 6 over x2 minus x1, which is minus 3 minus 0, minus 3 minus 0, like this. So definitely this is going to give you a 2. That is your gradient. All right, so in this case our gradient is a 2. Then determine the equation of the straight line. Write your answer in the form. We are given a condition of writing our answer in the form. So it's y is equal to mx. So remember, guys, m is the gradient, and we said our gradient is 2. So it is going to be 2x plus c. This c represents the y-intercept, and our y-intercept on the graph here, the graph is cutting the y-axis at 6. So the value of y there is 6. So it's going to be plus 6. So that is going to be the equation of the line. All right, y is equal to 2x plus 6, just like that. So that is what we had. So some of these questions, you can actually take advantage of the graph that you are given, work it from the graph, then it can make things easier actually. All right, so here on question 5.2, we are given xy is equivalent to 7. Complete the table. So actually this is supposed to be, remember the format of a hyperbola, y is equal to a over x. So actually you have to divide there by x, so it's y is equal to 7 over x, like that. So at least now we can complete the table by just substituting here, because you've got the values of x minus 7 minus 1, so you substitute here minus 1, so it's y is equal to 7 over x. So y is equal to 7 over x, which is minus 7. So when you have minus 7, this is going to give you minus 1. 7 divided by minus 1, which is minus 7. 7 divided by 1, which is 7. 7 divided by 7, which is 1, because this is 7. So these are the points that you have. Then draw the graph by making use of the given and use the graph paper there. All right, so what you're supposed to do, guys, is to make sure that you use your graph paper, because you'll be given the graph paper and so forth. But this is nothing actually. This graph is just going to look like this, whether you've got your graph paper there or you do not. You can understand what I'm trying to say here. These are the values of x from 1 up to 7. So you just make sure that you mark 1 up to 7. So you're going to have 1, 2, 3, 4, 5, 6 up to 7 there. Let's just put maybe another 8, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So you just make sure that you mark these points properly on your graph there. Minus 6, minus 7, 1, 2, 3, 4, 5, 6, 7, something like that. All right, so what you do is that you then mark your points. Minus 7 in x and minus 1 in y, which is minus 7 in x and minus 1 and minus 1 actually in y, which is this one. So you mark a point like this. All right, then minus 1 in x versus minus 7 in y. So it's minus 1 in x versus, so where these two meet, they are going to meet at a point like this. So that's where you mark a point. So it's minus 1 here and minus 7. Where these two meet, you just mark a point. Okay, you move on to the other one, because these are the points that you're given. This is 1 versus 7 and 7 versus 1. So the first one is 1 versus 7 here. So you mark a point at 7. And another one, it's 7 versus 1. So you mark a point here. So that means your graph is going to just be like this. All right, something like this. It's only here, it's a plain paper, but it's just going to be something like that. Here also, you've got something like this. From this point to this point, it just goes like this. Yeah, a curve. Just something, just supposed to be something. All right, something like that. So that is the idea there. So it's going to be your graph of xy is equal to 7, like that. So guys, that's what you just have there, and it's just direct. And the question is, determine the relation of x and y values of the graph. So what is the relation? Actually, this is a direct, guys, isn't it? A direct relation. About inverse, but this is a direct, that one. Then what is the name of the graph? This one is a parabola. Hyperbola, not a parabola. This is a hyperbola. A parabola is this one, that's a hyperbola, or this one, but this one is a hyperbola. All right, so you have to be very, very careful. Then define an isosceles triangle. So what do we have, guys? An isosceles triangle is all about remember, it's a triangle like this. That's an isosceles triangle. So you can define this in many ways, that two sides are equal. Actually, a triangle with two sides which are equal, and base angles, So it's not about sides also, but it's all about angles also. Then what are supplementary angles? Take note, whenever you work about supplementary, do not forget to write two angles, guys. These are 2 angles, actually 2 angles, not 3, but 2 angles, which add up to 180, which add up to 180. Is it 180? Yeah, that one is 180. While list complementary 2 angles which add up to 90, but these are supplementary. These are 2. Don't forget that 2. All right. So then the other part we are given there, triangle ABC, this one, and is actually similar to, okay, so these two, they are similar. Complete the following. All right, so remember guys, this one is from similar figures where we know that the ratio of sides is equal. So it's AB over, this is AB here, over EF. So it's over EF, which is equal to, you move on to this one, it's BC, B to C, this one, and FG over FG, which is A to C. You move on, you start with A, this A here to C. So it's going to be AC over this E to G. So it will be E over G, like that. So that is actually what they needed. So what you're supposed to complete was this piece here and this piece. So it's just half, which to make it 1 mark. Then solve for X, which is this X. All right. So the first thing, take note of your dimensions, guys. These are centimeters, but these are millimeters. So convert these to centimeters. We know that in a centimeter, it's actually 10 millimeters. So you have to just divide by 10, which is 15 centimeters. So this is 15 centimeters. So to find X, actually, you have to just substitute here onto this formula. Where is our X? Our X is on FG, which is this one on FG. So it's going to be BC over FG, which is BC. BC is there, this one. BC over FG, the one with X. So it's BC over FG. All right. So this is gonna be like this, 6.22. We said BC, this one, over FG, so it's 45 over X. So it's going to be 45 over X is equal to, then you look for another side which is complete, guys, which is complete. All right, so which other side is complete? We have got this one of AB and EF, AB and EF, this one. So you're going to equate to this one, which is AB in centimeters, 15. So it's 15 over 3 over 5. All right, like this. So you formulated an equation. You can solve this one for X. So how can I solve for X? So many ways. I can cross multiply. That's gonna be something like this. This one times this one, so it's 5 times 45 is equal to 15 times X. All right, which is 15X actually. So to find X, you have to divide again by 15 by 15. So that's our X here. So if we divide, actually this, we can just reduce it. All right, 5 times this one divided by 15, which is going to give us something like 15. Is that so? Because this is 45 divided by 15, which is actually 3. Then 3 times 5, which is 15. Okay, so our X is 15. All right, so you can just prove using your calculator, because it's allowed to use a calculator there. All right, so you can just prove and see if you're obtaining the same thing. Then this, we are actually given an isosceles triangle, the one that we're talking about there. Remember, we defined an isosceles, and there we are given both these two sides are equal. Then the question is, QR is extended to S. Calculate X, Y. X and Y, give reasons for your answer. So how can we have the value of X and Y? Okay, so let's start with this R1 here. Okay, R1 actually is equivalent to 70 degrees. This angle here is 70 degrees here. Why are we saying so? Because these are base angles. Okay, so you've got base angles of an isosceles triangle. So if this is 70 degrees, actually it can help us to find this angle X there. Why? Because these are angles on a straight line. So therefore X is going to be 180 minus 70, which is actually 110 degrees. That's angles on a straight line. So these are now angles on a straight line. All right, on a straight line. So this is going to give us 110 degrees, which is X. What about Y there? So Y, you can use so many concepts, angles in a triangle, or you can use the concept of what? Exterior angle, this one, because it's an exterior angle, is equal to the opposite interior. So it's just 110 minus 70, or you can just apply that Y is equivalent to 180 minus 70 plus 70. Why? Angles in a triangle. So it's going to be 180 minus 70 plus 70, which is actually 140. So this is going to be 40 degrees. So that is going to be the angle Y there. So this angle is going to be 40 degrees. So the reason is angles in a triangle. Angles in a triangle, they add up to 180 degrees. Actually, there are so many ways and concepts, so many ways, guys, and considerations that you can actually have. But that was to make it a total of 9 marks on that question. And on question 7, we are then given to simplify without the use of a calculator by just making use of the special triangle, the one that you're given there. So what do we have and what can we do? This is cos 45, and here we've got cos 45. Remember, cos, it's adjacent over hypotenuse. This is adjacent over hypotenuse, actually. So according to this 45 that you're given, this is your adjacent here, and this is your hypotenuse. According to this 45, and this is your opposite, actually. So remember, cos, it's adjacent over hypotenuse from soccer to like that. All right, so cos is adjacent over the hypotenuse, which is 1 over square root of 2. So which means in place of cos 45, I can just put 1 over square root of 2, 1 over square root of 2 like this, times. Is it a times? Yeah, that's a times. Tan squared that. So tan squared that. So first let's find tan that. All right, tan that, remember, tan opposite over adjacent, opposite over adjacent. So remember, this is your opposite and this is your adjacent, and this is your hypotenuse. So according to that, opposite over adjacent, which is 1 over square root of 3, but it's supposed to be squared. So it will be 1 over square root of 3 like this, squared. All right, everything over sine 60, which is sine 60. Definitely have to find it here because this is 30, 90, so this will be 60 here. Angles in a triangle, so this will be your 60 degrees. And according to 60 degrees, sine is opposite over hypotenuse. So according to this 60, this is your opposite. All right, this is your opposite here, according to 60. So it's opposite over hypotenuse, which is square root of 3 over 2. Square root of 3 over 2. That is what you're going to have from sine 60 from that part. So that is what we have, and we can simplify further, guys. As you can see, we have to simplify further depending with what we can do. What can we do here? We have got 1 over square root of 2 times, this is going to give us 1 over square root of 3 squared. This one is same as like this, 1 over square root of 3 times 1 over square root of 3. So square root of 3 times square root of 3 actually gives you 3. So it's 1 over 3 from your laws of scissors. This is going to be 1 over 3. Okay, then whatever that you're going to get here, this is dividing. This one is dividing. So you're going to multiply by 2 over square root of 3. Remember what I told you about multiplication. When you are dividing, you introduce multiplication, then you invert. So it will be 2 over square root of 3. So that means we can have 2 times 1 times 1, which is 2 over. Here, this can multiply each other. 1 times 3 times 1, which is 3, square root of 2, and square root of 2, which is square root of 6. So it's 2 times 3, which is 6. So you can actually write it like this, depending with what they are. But now they're saying without the use of a calculator. And according to our laws, guys, we can actually leave it like this, or we can choose to multiply to simplify further. But with the number of marks, guys, I don't know. Let's just do it. If it's going to help us, 2 over 3 square root of 6. So how do we do it? We multiply by 3 square root of 6, both the numerator and the denominator there. So that means we can have 2 times 3, which is 6 square root of 6 over 3 times 3, which is 9 times square root of 6 times square root of 6, which is 6. So this is gonna cancel, which gives you square root of 6 over 9, of which these laws now in our syllabus, guys, we can also have. So you can just leave your answer at that stage. Yes, they're gonna give you full marks for that. So just leave your answer at that stage. It's fine. No complications there. All right, so let's see another part, which is on 7.2. We are given the triangle TSR. Write down the following trigonometric ratios in terms of S, T, and R. So in terms of these letters that you're given, and the first one is sine R, which is this is your R here. So remember, sine, we said, is opposite over hypotenuse. So that means our sine angle of R is going to be opposite over hypotenuse, which is opposite. According to R, this is your opposite here, which is R over the hypotenuse, which is this one, which is S. All right. Then cos T, cos angle T, remember cos is adjacent over the hypotenuse. So according to T here, this is your adjacent according to T, and the hypotenuse is R. So it's going to be adjacent over hypotenuse, which is the adjacent, it's R over S. So this is something that they want you to understand. So it's R over S like that. This one is just like that. If A is equal to 30, B is equal to 40, use a calculator. This one they're saying use a calculator to simplify this. Sine A plus B. So what do they mean here? Sine A plus B, your A is 30, so it's sine 30 plus B, which is 40, like this. So this you can just add together, or you can just put it in your calculator. They said use a calculator, so you can just put it in your calculator. Sine open bracket 30 plus 40, like that, which is 0.9, something like that. So this is gonna give us 0.93969, of which this is gonna help us, and 10 and it's 4, so it's gonna be 0.940, something like that. All right, what about cos A, cos B? So this is cos A, cos B. It's just direct as it is. Cos, what is your A? Your A is 30 plus cos B. What is your B? Your B is 40. Now they say use your calculator. So it's just cos 40 plus cos 30 plus cos 40, like this. Cos 30, close bracket, cos 40, close the bracket, like that. So you're going to obtain 1,6, something like that. So this is going to give us 1,632, and this is just direct like that. So that is how they are asking these questions, guys, as you can see, and we have to be very, very careful. Just look, guys, and it's actually nothing at all. It's actually nothing at all, but you have to be very, very careful when attempting this question. Then the last piece which we have is on question 8, which is actually 14 marks, and we're just given there the price of a fuel is 13.88 rand per liter. It will increase to 14 rand 30, and from there we are asked to give or to calculate the percentage increase. Okay, it's just like what is happening now, the increase. So you're supposed to calculate the percentage, because every day there's an increase that is happening there. All right, so let's just see. Let's not get into what is happening. Let's just work out the question, guys. What do we have here? So initially we have got 13.88 rand per liter, and it will increase to 14, that is the increase. So which means actually the percentage increase is just like this, guys. Originally we had 13, then it increased to 14.30, like this. This is the increase. So you can just subtract the two. 13.88. All right, this is just subtract and see the difference. So it's 14.30, 14.3, just like 14.3 minus 13.88, which is 0.42. So it's actually increased by 0.42, and this was the increase. So what is the percentage of this increase? So we are going to say at initially when it was at this price, it was 800% initially at this amount here. So we are going to have 0.422 over the initial, which is 14.30 times 100%, so that we can see by what percentage that increase. So here we can just say divide by answer, which is divide by 14.3, not by answer but by 14.3. Then whatever that you get, you multiply by 100%. So you're going to have a decimal of 2.9, something like that, which is an increase. Isn't this big, guys? 2.94%. All right, let's just prove this and say, let's say 800%, it was costing this one 14 rand 30. Then no, not 14, but this one 13, the initial one 1388. That was 1388. So this one we do not know the percentage, but 800%, it was at 1388 with the original price. We want to use another method like this. All right, so when it is at 100%, that is the original amount, then it increased to this amount. So we want to know the percentage at this amount. So it's going to be 14.3 over 13.88 times 100. All right, so let's see 14.3 over 13, right, that's 14.3 divide by 13.88. remember it's 13.88 like this, then you multiply by 100%. So it's gonna be actually on top like 103. So it's 103.02 whatever that we have percent at this amount. Then we subtract the original, which is at 100%. So if we subtract 100%, it's going to be 3.025, which is 59, something like that. Was this the same answer that we obtained, or it's actually 2.9? Okay, so guys, just cross check there if there is any mistake that you're having on the calculator and so forth, but that is the idea there. Then the area of a right angled triangle is, we are given the area and the base is 3 centimeters. Calculate the height of the triangle. Okay, so this is a right angled triangle that we are given on 8.2 or something like this, and we have got the area of the triangle, and take note it's square centimeters, which is something that is good. 8 square centimeters, and we've got the base, which is 3 centimeters. So let's just say this is our base here, which is 3 centimeters, and we do not have this because the question is calculate the height of the triangle. This is the height, this is not the height, this is just the hypotenuse, this one, but the height of the triangle is this one, the one that you use when calculating area, where you use the formula of half base times what? Height, half BH, which is the area is there, it's 8. So 8 is equivalent to half times the base, which is the one that we have, times the height, because the base is there is 3, but we do not have the height. So where can we find this height? Okay, let's just multiply by 2 there, so this can cancel out. So it's 2 times 8, which is 16, is equivalent to 3h. So you want to calculate the height, divide by 3 by 3. So which means your height is going to be 16 divided by 3, and this is going to be just like that, 16 over 3, or you can write it as a decimal because your height is actually 16 over 3, or it can be a decimal of 5.333, something like that, in centimeters. So that will be the height there. So that is what we had on this area. So actually these questions, they can ask in any manner. What you need is to be very, very careful with the way that you can attempt or answer it. Then we are given a rectangular prism, and we have got the length of the prism, the breadth, and the height. And the question is to calculate the volume. So remember, if it is a rectangular prism, the volume is actually equivalent to LBH. That's the volume, which is 8.31. All right, so we have got LBH there. That is the length times breadth, or you can use length times width times height. Length times width times height depends with what you have. So we've got the length, the breadth, and the height. So it's 4 times 1,5, 4 times 1,5 times the height of 2. You just take the length as it is, the breadth as it is, the height as it is. Then you can actually multiply and obtain the answer there. So that's gonna give us 4 by 1,5 times 2, which was 12. So this was actually 12 cubic meters, and it's direct like that. Then the question now further asks us what is the capacity of the prism if 1 cubic centimeter is equal to 1 mil. And this is direct, guys. For each and every cubic centimeter we've got 1 mil, so this is 1:1, and us here we have got 12 cubic centimeters, so it's gonna be 12 because this one is direct, so it will be 12 mils, guys. 1 gives 1, so 2 is equal to 2, 3 is equal to 3, so 12 is also going to be 12. Then calculate the surface area of the prism. They actually, I wanted you to see how they give you the formulas there on your formula sheet. How do they give you? But anyways, let me just write it aside. This is what you're going to have from your volume. The surface area is going to be like this. This is 8.33 because from your formula sheet it's not there, so you multiply from this one, you take it from this one, it's LB, so it's going to be 2 LB plus LH plus BH, like this. You just combine these three together. Okay, so that's going to be 2 into LB plus LH plus BH, like that. So remember, you have got L and B. This was our L, our B, and our H. So our L is 4 times 1,5, all right, plus LH, which is 4 and 2, all right, plus 4 times BH, which is 1,5 times 2. So it's just like that. So that's what you're gonna have there for the total surface area. So what you just need actually is to also apply on your calculator properly. Just put everything in your calculator, then you're gonna apply. You're gonna have something like 34 there. This is area, so remember area in square centimeters. So this is gonna give us 34 square centimeters, and that's how they ask these questions. Somehow the last question, that's how it is like. So like I said, guys, just cross check on the first question there on from these last questions and see if that was a mistake or on our calculator or so forth, so that we can see how we are supposed to answer it. So that's what we have, guys, from Memo African Motives, working on mathematics for N1 level. So if you are new, you can consider being part of the family by subscribing, so that you won't miss any of the classes or any of the videos that we shall be having for mathematics N1, working on question papers and revisions. So as we prepare ourselves for the exams which are ahead of time, till we meet again.